Experiment number 18, input characteristics and output characteristics of a transistor, and also find the current gain and voltage gain. Here are the observations. So these are the range and least count of the voltmeter and millimeters which are used in the experiment. So table number 1. So table number 1, this is the variation of the input current IB with the input voltage VBE for fixed value of VC. So here we are fixing the value of VC. First time we will keep the value of VC is equal to 2 volt, then VC is equal to 3 volt, VC is equal to 4 volt and VC is equal to 5 volt. And here VBE value we are changing from 0.1 to 1 volt. And here the values are written in the column. First column, this column, then the next column, this column and this column. These are the values of IB. IB is the base current that is measured in a microampere. So first various values of IB and the corresponding value of VBE. So the last value is 75 microampere. Similarly, when the VC, that is the voltage between the collector and emitter, output voltage, it is kept at voltage 3, then various values of VBE and the corresponding value of IB are written here. Similarly, VC is kept at 4 volt, then the values of VBE and the corresponding IB. Similarly, last column, VC is equal to 4 volt, values of VBE and the corresponding IB. So in this all the 4 various values of VC, here we can see that VBE value is not changing. For all VC, whether it is 2 volt, 3 volt, 4 volt and 5 volt, the VBE will be fixed, but we can see the IB value is varying. That is table number 1. Next, table number 2. This is the variation of IC with the output voltage VCE for fixed value of IB. So this is used for finding the output characteristics, and the first table is used for finding the input characteristics. So here the value of IB is fixed, that is IB means the base current or input current, that is fixed, and then we are changing the value of IC or VCE we will change, and the corresponding IC value we will measure. That is VCE versus IC is the table number 2. So here the VCE, various values of VCE, that is collector emitter voltage or output voltage from 1, 2, 3, 4, 5, 6 till 10. And first the IB value we are keeping as 30 microampere, and then the various values of VCE. The IC values are measured and we are writing that here. That is from 11 to 15 for a voltage 1 to 10. Similarly, IB is equal to 40 microampere. That is a fixed input current. For various values of output voltage VCE, the corresponding AC values 15 till 20. Last reading is not there, it is coming out of range. So similarly, for IB 50 microampere, that is fixed, then changing the VCE and writing the corresponding ICs in the third column. And last one is for a IB is equal to 60 microampere, the various values of VCE and the corresponding IC we will write in the column. And here the only this much experiment you have to do. So table number 1 and 2 if you have completed, this experiment is over, the remaining is calculation. Okay, so the next again another table is the table number 3. So that table is drawn by using table number 2. So here variation of output current IC with the input current IB for fixed value of VCE. So here I have written only 4 values, that is enough. Okay, so here the values of VCE I am fixing 2 volt, 4 volt, 6 volt and 9 volt. I already told you this table is drawn from table number 2. So VCE is 2, 4, 6, 9. Many values of VCE, around 10 values you have written there. So any 4 values of VCE we have to select from table number 2. I am selecting 2, 4, 6, 9. So this is the VCE, table number 2 VCE is here, 2, 4, 6, 9. And the corresponding IBs VC is 2469 and IBs are 30, 40, 50, 60. 30, 40, 50, 60. So that you will write here the first column 30, 40, 50, 60. What are the VCs? VCs are 2, 4, 6, 9. So now note the VC 2 volt and this first this column and next column, in every column we are writing ICs. So here this is one type of IC, next one is also IC, this is also IC, the last one is also IC. So VC is equal to 2 volt. First IC is 11 corresponding to 30 microampere. Next one 15 corresponding to 40. Next one 19 corresponding to 50. Then 24 corresponding to 60. So therefore we can write the value of IC 11, 15, 19, 20, 24. Here 11, 15, 19, 24. Similarly, VC is equal to 4 volt. VC 4 volt. So these are the values of ICs and IBs are 30, 40, 50, 60. So IC first one is 12 for a 30 microampere. The next is 16, 21, 25. 12, 16, 21, 25. See here 12, 16, 21, 25 for a 4 volt. IB is not changing 30, 40, 50, 60. Similarly 6, 13, 18, 23, 28. 13, 18, 23, 28. The last one is for 9 volt. It is coming 14, 20, 25, 30. 14, 20, 25, 30. So table number 3 is over. Next is graph. First graph is VB versus IB. VB along the x-axis, IB along the y-axis. IB is in microampere and then VB is in volt. And also you have to write a scale. That scale is, every student you have to write a scale. X-axis 1 centimeter is equal to 0.1 volt and y-axis 1 centimeter is equal to 10 microampere. So that way you have taken the mark the values. 1 centimeter is 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. Similarly, y-axis 1 centimeter is 10, 10, 20, 30, 40, 50 till 110. So here I am marking some the values of VBE versus IB. So for that, so only one graph. We know a set of 4 set of IBs are there. 4 set of these, first set, second, third, fourth. So what will we do? I have marked the various values of IB in the third set. These values of IB, these are values of IB for a voltage VC is equal to 4 volt. And VBE is 0.1, 0.2, 0.3, 0.4, etc. No change. So these values of VB along the x-axis and these values of VC along the y-axis. So the plotting is very easy. Till 0.6 there is 0. Then 0.7 is 20. So 0.7 is coming here. Listen. 0.7 on the x-axis here and 20 y-axis. So mark the point. Next one is 0.8, 50. Then 0.9 it is coming 80. So join these all the points, you will get the first graph. Second graph is VCE versus IC. VC along the x-axis and IC along the y-axis. VC is in volt and IC is in milliampere. So this is the second table. So here I have all the 4 sets of ICs graphs are drawn here. Okay, you have to draw all the 4 sets of IC graphs. So first IB is equal to 30 microampere. So this graph, all the 4 graphs are drawn. I will explain the first graph. So here VC along the x-axis and this is IC. These are the various values of ICs for a constant IB 30 microampere. So first is 1 volt and the corresponding IC is 11. So look at the graph. First VC is equal to 1 volt. This is the VC 1 volt along the y-axis 11. Next again 2 volt also 11, 3 volt also 11. Next 4 volt it is coming 12 and 5 volt also 12 then 6 volt 13, and 7 volt 13, 8 volt 13, and 9 volt 14. So you have to join these points, and it's not necessary that all the points you have to join, and it should be a curve like this structure. So that way you have to plot the graph. This is IB is equal to 30 microampere. Second one is IB is equal to 40 here. That graph also we have to draw. In that case, the value of CE along the x-axis, this is VCE, and y-axis we have to mark the value of IC. So the graph will be coming like this. So if you are not marking all the points in the graph, it's okay, no problem. Okay, so you have to draw a curve-like structure. So next one is for IB is equal to 50 microampere, it will be coming like this, and IB is equal to 60, the graph will be coming like this. This is the second graph. Third graph is plotted by taking IB along the x-axis, IC along the y-axis by using the table number 3. So here I have used only the first set of IC, this set, for a VC is equal to 2 volt. Okay, IB no change, 30, 40, 50. So that IB we are taking along the x-axis and IC along the y-axis. So here also you have to mention the scale on the x-axis. Every graph you have to mention this scale. So on the x-axis 1 centimeter is equal to 10 microampere. 10 microampere. 1 centimeter is equal to 10 microampere. And y-axis 1 centimeter is equal to 2 milliampere. So that way the labeling is done on the x and y-axis. Now look, plotting the graph, first one is 30, 30, 11. 30 along the x-axis, 11 along the y-axis, here it is coming. Next one is 40, 50. 40 along the x-axis, 15 along the y-axis, here. Next, 50, 19. 50 along the x-axis, 19 along the y-axis. Last one, 60 along the x-axis, 24 along the y-axis. So joining this all the points, you are getting a straight line. That shows that IB and IC are directly proportional. It means input straight line is getting. So this IB and IC are directly proportional. That is why you are getting a straight line graph. Now the calculation of input resistance. Input resistance equation is delta VBE by delta IB for a VC is equal to constant. So here the constant VCE that I am taking, VC is equal to 4 volt constant at a 4 volt. The VC is equal to 4 volt. At that time, the difference between VBE, change in VBE upon the corresponding current. So here I am taking two VBE, you know this is VBE graph, VBE column. So one VBE I am taking 1, the next one is 0.7. So delta VBE means 1 minus 0.7. And corresponding IB, 105 minus 20. Okay, that is the value of IB. Okay, so 105 and 20 difference. That difference will be delta IB. So here I have done that one. Delta VB is 1 minus 0.7 divided by 105 minus 20. And here you remember IB is in microampere. That is why I have multiplied here 10 raised to minus 3. Sorry, minus 6. So finally the answer will be 0.3 divided by 85, or 10 raised to minus 6 will be coming to the numerator plus 6. Then finally when you multiply with the 10 raised to 6, you will get the answer 3529.4. This is the input resistance. Next one is output resistance RO. It is calculated by using the equation delta VCE by delta IC for a constant IB. So here using the first second column. In the second column, you know, you are writing ICs, that is a collector current, and here I am selecting two collector currents, 14 and 11, and the corresponding voltages are VCE are 9 and 1. So difference between 9 and 1 that will give you delta VCE, and the corresponding difference of 14 and 11 will be delta IC. And here the calculation, delta VCE 9 minus 1 of the voltage, initial voltage, final voltage 9, initial voltage 1, divided by 14 is the collector current IC, 14 minus 11, and both this IC is in milliampere, so we have to multiply with 10 raised to minus 3. So here we will get 8 by 3 into 10 raised to minus 3, or it will be 2.667 into 10 raised to 3, or 2666.7 ohm. Next one is the current gain beta, that is delta IC by delta IB for a constant VCE. So here delta IC, look at the first next column, second column. This is the values of IC, first ICs. So here we are using 24 and 11 are the two ICs. Difference will be delta IC, and the corresponding IB is 60 and 30. Okay, equation is delta IC by delta IB. Here 24 minus 11 by 60 minus 30, and you know IC is in milliampere, so therefore 10 raised to minus 3 will be coming in the numerator, and IB is in microampere, so 10 raised to minus 6. So finally 10 raised to minus 6 and 10 raised to minus 3 are cancelled, then you will get 10 raised to 3 at the numerator. So 13 by 30 into 10 raised to 3, finally you will get the answer 433.3. This is the current gain. Last one is the voltage gain AV, that is beta into RO by RI. Beta is the current gain, RO is the output resistance, RI is the input resistance. Beta is 433.3 multiplied by RO is 2666.7 divided by RI is 3529.4. Answer will be 327.39. The last is the result. The characteristics of the transistor as shown in the graph. At VC is equal to 4 volt, the input resistance RI is equal to 3529.4 ohm. And next one, there is a small correction is there. At IB is equal to 30 microampere output resistance. Here output resistance is there. Output resistance is RO. It is calculated by using constant IB. So you have to make the correction. IB is equal to 30 microampere. The output resistance RO is 2666.7. Next one is current gain 433.3. Last one voltage gain 327.39. This event is over.